Welcome to Nexus Medical Media. In this video, we'll be talking about de novo pyrimidine and purine synthesis. So, first we're going to write down the pathway, what happens, and then next we'll cover different drugs, immunosuppressive, antineoplastic, and antibiotic drugs that interfere with the nucleotide synthesis. Right, so let's begin. We're going to start our journey talking about the pyrimidine base production. Right, so the first step is a combination of glutamine with carbon dioxide, and here we form carbamoyl phosphate. The enzyme for this step is called carbamoyl phosphate synthetase 2. Next we will form orotic acid. Orotic acid is formed by adding aspartate, and the enzyme responsible is called dihydroorotate dehydrogenase. Dihydroorotate dehydrogenase. The next step is formation of uridine monophosphate, and the enzyme is UMP synthase. Next we will form UDP. This is just phosphorylation. We just added one phosphate, uridine diphosphate. Right, so from uridine diphosphate we can form cytosine triphosphate, or we can form deoxyuridine diphosphate. Right, and for this step the enzyme is ribonucleotide reductase. Ribonucleotide reductase. From deoxy-UDP we form deoxy-UMP. Right, we just removed one phosphate. So here you have your deoxyuridine monophosphate. This is converted to deoxypyrimidine monophosphate, and the enzyme responsible for this step is called thymidylate synthase. Thymidylate synthase. But this enzyme needs tetrahydrofolate. Right, so tetrahydrofolate will work on this step. Right, so it will work on this step, right, because it's needed as a coenzyme for thymidylate synthase. Right, so as a result we have dihydrofolate. Right, so we need to convert this dihydrofolate back to tetrahydrofolate. Right, so it means we need to reduce it. Right, so the enzyme responsible is called dihydrofolate reductase. Dihydrofolate reductase. Okay, so this is the basic pyrimidine base production. Right, now let's look at the purines. Right, so we have the hexose monophosphate shunt, or the pentose phosphate pathway. It yields ribose 5-phosphate. This ribose 5-phosphate is converted to phosphoribosyl pyrophosphate. Ribose 5-phosphate is converted to phosphoribosyl pyrophosphate by the synthase enzyme, and then this PRPP is shunted here to make the purine bases. Right, so in de novo synthesis of purines, it requires aspartate, glycine, glutamine, and tetrahydrofolate. Right, so there are a lot of steps involved. Right, but at the end here you have IMP. IMP, what does IMP mean? It means inosine monophosphate. Right, so inosine monophosphate, it can either form adenosine monophosphate, this, or it can form GMP, guanosine monophosphate, here. Right, so in this step it involves an enzyme called inosine monophosphate dehydrogenase. Inosine monophosphate dehydrogenase. Now we need to start again this pathway so that we have a closer look in each and every step, and we address if there is anything that you need in your head to stick. Right, so on the first step, this step uses ATP. Right, so 2 ATP. ATP will run here, and as a result, what do we have at the end? We have 2 ADP, 2 ADP plus a phosphate. What else do you have? You have glutamate. Right, so these are the end products that you get from here. One thing you need to remember about the enzyme for this step, carbamoyl phosphate synthetase 2. This one is found in the cytosol. There is another enzyme with similar name called carbamoyl phosphate synthase 1. This one is found in the mitochondria. And the process where you find this enzyme is called urea cycle. Right, so don't confuse that enzyme with this one. This one is specifically found in the cytosol. Alright, so the next step is carbamoyl phosphate, combining it with aspartate. Right, in this case, the enzyme we use is dihydroorotate dehydrogenase. Alright, so this enzyme is actually inhibited by a certain drug. Right, the drug is called leflunomide. Right, so leflunomide. Right, so this inhibits the enzyme here. Right, so what else do you need? Again, here on the next step, from orotic acid to UMP. Right, the enzyme we use is UMP synthase. Right, so this enzyme is the one which is impaired if we are talking about a condition known as orotic aciduria. Orotic aciduria. It means if you can't convert orotic acid to UMP, it means you have high levels of these. Right, so you find this orotic acid in urine called orotic aciduria. Right, so the next step is here when converting a UDP to deoxy-UDP using an enzyme called ribonucleotide reductase. There is a drug that inhibits this enzyme. Right, that drug is called hydroxyurea. Right, it's an anti-cancer drug. Right, so the next step, we are looking at the enzyme which are inhibited by different drugs. Right, so if you come here on thiamidylate synthase, is right here. Right, so this is inhibited by which drugs? Right, can you guess? These are very common drugs that inhibit. The first one is called 5-fluorouracil. It's 5-FU, 5-fluorouracil. Right, it is a prodrug known as capecitabine. Okay, capecitabine. Right, so these two drugs, 5-fluorouracil and this prodrug capecitabine, will inhibit thiamidylate synthase. Right, another enzyme that is targeted by a very important drug is this one, dihydrofolate reductase. Right, so is inhibited by drugs like methotrexate. Right. What else? The next drug is called trimethoprim. And the next is called pyrimethamine. Pyrimethamine. Right. So these drugs in their order, the first one will inhibit this enzyme dihydrofolate reductase in humans. Right. So this one will be humans. And the next drug, trimethoprim, in bacteria. And last but not least is pyrimethamine. This inhibits dihydrofolate reductase in protozoa. Right. So if you know a drug combination used for malaria prophylaxis called SP, right, is sulfadoxine pyrimethamine. Right. So that's pyrimethamine targeting the malaria protozoa. Right. Okay. The next step that we need to try and inhibit here is this drug. This enzyme called inosine monophosphate dehydrogenase here. Right. So this is inhibited by the following drugs. The first one is called ribavirin. Ribavirin is an antiviral. Ribavirin. And the next drug that inhibits this enzyme is called it's called mycophenolate. Mycophenolate. Right. Another step that is inhibited by this important drug is on synthesis of IMP. Right. So there are a lot of steps involved here, are inhibited by drugs like 6-mercaptopurine. That's the first drug, and another one is called azathioprine. Azathioprine. Right. So these are the steps which you take in synthesis of pyrimidine and purines, and those are the different enzymes used and the drugs that can be used to inhibit some of those steps. Right. So thank you so much. Thank you for watching. I hope you enjoyed. I hope you learned something. So you are free to replay the video, right, so that you catch each and every step. Thank you.